Okay, so your first composite shape that you're going to see, again, we talked about composite solids being two or more 3D solids that are combined together somehow. We're going to find the volume of each, and we're going to leave our answer in terms of in terms of pi, just so it makes it easier. This picture is trying to show you that we could have two cones kind of glued back to back using their circular base. Both cones, as you can see, have a height of 8 centimeters, and if they share that circular base in the middle, that means they both have a radius of 6 centimeters. So your game plan here is to find the volume of one cone and just double it because they're both the same exact size, and that way you could get the combined volume of this entire composite shape. So once again, we're going to make sure we use our volume of a cone formula, pi r squared h divided by 3. Again, our radius is 6, so we plug that in. Make sure we square it, multiply by the height of 8. 6 squared times 8 still has to be divided by 3. So if you did the calculation on 6 squared times 8, you should get 288. 288 divided by 3 is 96. So you can see I just wrote down the 96 pi. I never touched the pi button on my calculator, so I have to have pi in my answer. I'm going to double this number because, again, there's two different cones. This cone has a volume of 96 pi, and so does the other one. So when I do that, I get 192 pi for the volume of this composite solid. Your next example doesn't have two cones stuck back to back. What we have is a little cone that kind of forms the roof to this cylinder. So we're going to need to use our formula for a cylinder, but we're also going to need our formula for a cone for this top piece. You can see how I've organized my work. You're going to indicate, where you're doing the volume for the top shape, and you're going to indicate where you're doing the volume for the other shape so we can follow your work. The cone at the top, see, it has a radius of 3. The height is 4, so we've got our 3 radius plugged in. We're going to square it and multiply by the height of 4. If you do that, 3 squared times 4 is going to give you 36, but remember, you have to divide by 3 because it is a cone. So that's where the 12 pi comes from. Your cylinder has a slightly higher height to it, so make sure you use 8.5 for the height for your cylinder. You do have the same radius. The bottom of the cylinder is the same as the circular top, which forms the base of your cone. So that's why your radius is still 3 for this problem. So we've got our 3 squared. We've got it multiplied against 8.5, and we do get a volume for just the cylinder piece, the bottom shape, 76.5. Because we're combining the two shapes together to form one big composite shape, we have to add those numbers together. So we should get 88.5 when we do that. And again, your answer is in terms of pi because we never actually multiplied our numbers by pi. We kept pi in our answer. You're probably noticing also on my note sheet that I've approximated my answer by actually multiplying those two cones who had the volume of 192 pi. Comes out to be approximately 603, and this is supposed to be centimeters cubed. And for the bottom question, we had centimeters also. So if we add our units, now we are more correct. There's 3 more examples. What I would like you to do is I would like you to figure out what pieces of the problem that you have, and I would like to have you try these on your own before you watch the next video. This, as you can see, is made up of 2 cones that are kind of connected. Kind of reminds me of one of those hourglass where you might have the sand going down through to the other side. But really it's broken down into 2 cones, this larger cone at the top and the smaller cone. And then again, when you read these questions, you're going to draw yourself a diagram so that you can see what shapes you have and how you would find the volume after that. So again, try these on your own, and then I'll have you watch the second video to check your work and make any corrections as needed.